LangChain is one of the hottest AI frameworks right now with over 40,000 stars on GitHub as of this video. Let me help you understand some of the most important aspects of LangChain and why it's such an amazing library to work with. Most of us have used ChatGPT and are quite fascinated by its capabilities. So you can ask something like write in the style of Shakespeare, how to cook pasta. So what happens behind the scenes is that it takes your input and sends it to an AI system as a prompt, and that generates a response which is provided back to you. And often these systems are called large language models, which are trained on a huge amount of text data from the internet. Now, I want you to imagine a scenario where you are an instructor and you want your students to use ChatGPT and submit all of their assignments in the written style of Shakespeare. So you can imagine that most of our students are prompting ChatGPT to write in the style of Shakespeare. And this is quite a waste of time due to the repetition of the same prompt by so many people. So to help out our students, we decided to build a ChatGPT style app which has a base prompt to write in the style of Shakespeare. And it combines that with the user input and sends all of that combined together as a prompt to the large language model and gets a response back. This technique of combining user input with a base prompt can be easily achieved in LangChain using a concept called prompt template. Prompt templates are quite powerful in the sense that you can give specific instructions to an LLM as how to behave or how to respond to the prompt. You can say something like you are a helpful assistant or you are an expert in the area. These will change the response back from LLM drastically. Now, our application is working great. We just want to add the capability where we could call any of the available LLMs. LangChain makes this very easy, where we could swap out any of the LLMs listed under the model section. You might have noticed that there are a few steps happening here where we take the prompt template and provide the user input to it, and then specify the LLM before we make a call to the LLM for the response. LangChain makes it easy where we can link all of these components together by something called chain. Chains are core building blocks of LangChain, which can help us achieve a specific task by linking multiple components together. There are many different types of chains available in LangChain, and these chains are often named after the task they perform. In our earlier example, we wanted to call an LLM. The chain for that is LLM chain. If we would like to perform math problems, the chain for that is LLM math chain. And if we were to perform SQL operations, the chain for that is called SQL database chain. And if we were to retrieve an answer, the chain for that is retrieval QA chain. These are some of the many available chains in the LangChain library. Now, question answering chains have a special place in the LangChain library, so I would like to expand on this a little more. Let's go back to our example where now we want our students to use ChatGPT to answer questions or search from entire books. So if they were to copy the text from these books and paste in ChatGPT, most likely they'll get an error like this, which says that it was too long for ChatGPT to process and give answer. Now, the way we can overcome this is using LangChain. In LangChain, the typical Q&A process starts with first loading the document with something called document loaders, which helps us extract the text from source documents. And there are a number of document loaders available in LangChain which support a variety of document formats. Now, once the text is available to us, we need to split that text using something called text splitters, which takes the long pieces of text and convert it into small chunks. Now, the next step is to take these chunks of text and convert it to numbers using something called embedding models. The way these embedding models work is that they take the text and assign it a number based on their meaning. So words and sentences which are similar in meaning are closer to each other in the numbers that are assigned. The next step is to store these numbers in a storage called vector stores or vector databases so that we can later retrieve them. Now, this completes the embedding path or indexing of these documents. The retrieval process starts with vector stores where we have a number of vectors available. Now, to help us understand visually, let's imagine these vectors are in 2 dimensions with x and y component, which we can plot on an xy plot in a way that similar meaning vectors are closer in proximity on this xy axis. Now, once a user asks a question, then that question is also embedded in a similar dimension and then compared against the vectors available to us. And there are a number of ways we can retrieve these vectors. One of the most common ones is to do a similarity-based search where we select the nearest neighbors to our question and retrieve those vectors and convert them to original text form and then generate our response based on those text pieces. So essentially, now we can take any of the document and store it in vector stores. And when we get a question, we can retrieve the answer and then generate a response, which means that our students can now search through entire books and get response back from our chat application using the retrieval QA chain. Now, what if we want our chat application to not just search entire books, but also perform SQL operations, as well as search internet and a few additional tasks? The way we can achieve this in LangChain is using one of the most exciting features that is agents. LangChain agents are assistants who have access to tools and can perform tasks using those tools. And these agents could be communicated using similar chat interface where if we were to ask them question from the book, they know which tool to use, and in this case, to use the retrieval QA chain. And if it were a question about SQL operation, then they know to use that particular chain. There are a number of agents and there are multiple tools available for these agents in the LangChain library. You can search internet, you can access shell, you can also access the thousands of tools available in Zapier, as well as you can run Python function. Not just that, you can use chains as tools, as well as custom functions and also other agents as tools. Now, what if we want our agents to remember our conversations? For that, there is something called memory in LangChain. And there are many different types of memories that can be configured to run with either agents or chains, and it helps them remember our conversations in either short term or long term and can be accessed by our application as needed. And what if we want our application to generate a response in a way that we could use it downstream? So maybe we want in a JSON format or we want in a particular format. To do that, there is something called output parsers. Output parsers make sure that the response from the LLM is in a certain format, which could be then used downstream.